In the previous video, we discussed the sheet-like microstructure of clays. In this video, we'll examine the different ways clay particles can exist in water. The clay particles in water are under the influence of a number of different forces. There are repulsive forces stemming from electrical double-layer repulsion, Born repulsion, and desorption of water, as well as an attractive force in the form of van der Waal forces. A deflocculated system, or a dispersed system, is a system of suspended particles where there is an overall repulsive force between the particles. Such state can be achieved by creating conditions in which the particles carry the same charge. We can do that with a clay system by putting it under alkaline conditions, because clay systems often have a net negative charge under such conditions. Dispersion and deflocculation of clay particles is crucial because they are required for optimal rheological properties of the drilling fluid. As explained before, the sign and magnitude of the surface charge controls the state of deflocculation or flocculation. Like charges repel and opposite charges attract. The more like charges we have on the surfaces of the sheets, the more dispersed the clay will be. These surface charges can be controlled by pH, salts, and polymers. The dispersion can also be increased by mechanical mixing and shear. A flocculated system, on the other hand, is a system where there is a net attractive force between the particles. The particles in flocculated systems can associate with one another and form loose structures. Unlike a flocculated system where only loose structures form, thin sheets of molecules combine to form thicker sheets in aggregated systems. Such behavior decreases the number of particles in the suspension and decreases its viscosity. Aggregation can be caused by the addition of divalent cations, like calcium 2+. This is problematic because drilling anhydrite or cement will introduce these species to the drilling fluid. When calcium salts are introduced to a dispersed sodium montmorillonite system, the calcium ions bond different particles together, as explained earlier. Polyvalent ion bridges are formed. The particles within the loose structures then undergo ion exchange reactions, forming the thicker, aggregated sheets of clay. Flocculation, deflocculation, aggregation, and dispersion are all terms that describe how closely packed the clay particles are. The shown figure summarizes the difference between the four terms. Flocculation and deflocculation are terms that describe if the individual sheets of molecules attract or repel each other. Deflocculated systems are shown in the left column, where the particles repel each other and hence are separated. On the contrary, the flocculated systems shown in the right column contain particles that attract each other and are hence more closely packed. pH level determines whether a system is flocculated or deflocculated. Aggregation and dispersion describe whether the thin sheets have combined to form thicker sheets. The top row shows two dispersed systems where the clay particles remain as thin sheets, whereas the bottom row shows aggregated systems where the particles have combined to form thicker sheets. However, aggregation and dispersion does not describe whether the sheets attract or repel each other. The type of the cation present dictates whether a system is dispersed or aggregated. In this video, we visited flocculated systems and aggregate systems. We looked at what kind of systems the two terms describe, how to keep a system deflocculated, and what causes a system to be aggregated or dispersed.